Visual homage inherited and carried valuable cinematic knowledge through many masterpieces. Similar cinematic effects are countless and can be found everywhere in modern films and even digital entertainment. The question we raise in our work today is, can we achieve automatic cinematic transfer with the help of developed computer graphics and computer vision techniques? We start with a dynamic NeRF representation of a scene by taking multiple views as input, and that has the capacity to then synthesize views on different camera angles, time and focal length. Then, by giving an in-the-wild shot reference, we design two networks to extract character pose heat maps and optical flows from the reference and synthesized views separately. Finally, the losses of the two networks go through a sparse sampling guidance map. By optimizing these cinematic parameters, camera motion, animation timing, and focal length, we show that we can achieve cinematic transfer from an in-the-wild reference shot to a new unseen scene in a NeRF representation. Here we show more examples. Let's take a difficult example, the dolly zoom in 1975 JAWS by Steven Spielberg. We clearly see that the image's background are compressed and the foreground amplified, the signature of a dolly zoom effect, and we can indeed transfer these cinematic characteristics to a new scene. Another possible application of our work consists in using JAWS as a way to compute a cinematic sequence in a graphics engines, such as Unity, to generate a camera trajectory according to a reference shot. Given just a wild shot as input, we estimate a 3D trajectory that reproduces similar visual effects in a NeRF reconstructed version of the 3D scene, and copy that trajectory to the original Unity scene. Artists are still able to edit this trajectory in the graphics engine. Here are some results generated by our system. Here we show results of ablation on loss. We carry out our ablation by video copying task. The idea is to retrieve similar image sequence results from a generated reference clip in the same or different NeRF scene, with close or far initialization position to show the perturbation level. Under the same scene, a NeRF-based method works well, so as the optical flow method when the starting point is the same, a drift can clearly be noticed on flow method with different initialization methods, but is not observed in the pose. We combine flow and pose methods as one supporting composition and another guiding the relative motion. Our method competes the visual copying task with pixel-based NeRF method, and is robust across different scenes, whereas the pixel-based methods don't work at all. Here we show ablation results of temporal and focal length parameters. Our method can query correct temporal and focal length parameters by optimizing on all parameters with a given reference. Here we show some limitations of our method. There are two main reasons limiting our system's performance. First, when the target character pose is very different to the reference one, undesired performance might be given as a compensation to the different pose. Second, when the character becomes unrecognizable due to rendering quality or lighting condition, the method may ignore the composition due to the lost characters.